Good day, this is the Professor, CBMD PhD, and today's Monday, October 2nd, 2023. It is 4:23 and 9 seconds, AM Eastern Standard Time, and today's research, silicon anode, materials. So let's jump to it here. Unlocking the potential of silicon anode, materials, for commercialized batteries. Date September 28, 2023. Source: also National Institute of Science and Technology. As silicon has emerged as a promising alternative to conventional graphite anodes and high-energy lithium-ion batteries due to its exceptional gravimetric capacity. However, intrinsic issues such as severe volume expansion during cycling have hindered the widespread use of Si anodes in battery development. While laboratories have made tremendous progress in addressing these issues, most Si-containing batteries used in industry for Si anodes are composed of Si suboxides or SiC composites are only able to incorporate limited amounts of silicon. The research team comprehensive analysis explores crucial factors that influence the potential energy density of silicon-containing batteries. It examines phenomena such as electrode swelling and cutoff voltage during cell operation, while considering calendar life, safety concerns, and cost implications, all essential aspects that significantly impact practical cell design. And furthermore, the paper proposes testing protocols aimed at evaluating the feasibility and viability of newly developed silicon anodes. These protocols offer valuable insights into ensuring optimal performance, efficiency, durability, and safety when incorporating these advanced materials into commercial battery applications. One key finding highlighted by the team is that reducing the size of silicon particles to less than 5 nanometers while uniformly dispersing them within conductive carbon particles holds great promise for overcoming existing limitations. Recent advancements reported by researchers involve depositing raw materials on carbon composite particles through gas deposition, a synthesis technology capable of reducing particle sizes below 1 nanometer. This innovative approach demonstrated initial efficiencies exceeding 90% with significantly improved lifespan characteristics. And this is a professor of space technology, advanced physics, mathematics, computer science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.